history, aviation has had an intimate relationship with the weather. In aviation, the word weather tends to be used to mean not only what's happening now, but also what will be happening during the flight. And based on the answer received, the pilot will opt to continue or to cancel his flight. In this presentation, I will examine the thunderstorms and how they affect the flight. So, thunderstorm is a complex of the atmospheric phenomena characterized by cloud formation and frequent electric charges. The meteorologically assigned cloud type associated with thunderstorms is cumulonimbus. It produces many hazards to the aviation community. To produce thunderstorms, there are several ingredients which must take place. There are an unstable air mass, moisture in the low levels, and something to trigger them. For example, daytime heating or cooling upper level. So thunderstorm cause major air traffic delays because pilots try to avoid their dangers. Lines of thunderstorms cause airplanes to make long detours around them, while storms near the airport can stop takeoffs or landings. Thunderstorm danger can include a fierce up and a strong wind, called updrafts and downdrafts. This is called extreme turbulence, that is caused hard to control an airplane. Near the ground, thunderstorms sometimes can create quite quick changes in wind speed and its direction. This phenomenon is called wind shear, which has caused many crashes of the airplanes. So hailstones can heavily damage airplanes, including breaking windshields and turbine blades in jet engines. Rain can sometimes heavily damage airplanes, including also jet engines. Lightning can temporarily blind pilots, and it also regularly hits airplanes and can damage electronic equipment. To ensure the safety and regularity of flights, needed timely information about thunderstorms in the areas of airports and takeoff or landing. Information about thunderstorms is provided by the form of storm alerts and warnings. To provide meteorological flights, the great importance plays thunderstorm forecasting. Frontal thunderstorms are forecast by a weather analysis, by calculating their direction and speed of atmospheric front's movement and assessment of its evolution. So, and for the air mass thunderstorms, forecasting used computation methods with the data of radio sounding of atmosphere. During forecast, it is considered the next methods: the synoptic station, the energy of the atmospheric instability, air temperature, moisture content, their layer, wind speed at the top of the troposphere, and some other characteristics. The result of forecasting gives just approximately information. It can be error between the forecasting value and actual value during the needed time. At meteorological stations, there are visual and instrumental observation. So the visual observation are based on the fixation of thunder and lightning, which because of noise of the airplanes and lightning of aircraft heavily massed. So visual observation have a number of disadvantages. the observer can fix weather station thunderstorm if it placed only at the distance of 10-15 kilometers. But the distance between the weather radar station is rather high. That's why some thunderstorm in this area cannot be fixed. So for the instrument observation, next system I use, such as weather surveillance radar, thunderstorms, bearing finder, and storm indicators. So let's briefly consider each of this. So with the help of weather surveillance radar, we can define the direction of the wind and velocity of its movement, the distance of the storm, the height of the upper thunder clouds, the detection droplets of precipitation size, strength of the radar return, in another word it's called echo, depends on drop size and its number. The greater the number of the drops, the stronger is the echo. And the larger is the size of the drops, the stronger is the echo. And airborne weather avoidance radar are used for avoidance service, whether not for penetrating it. Whether to fly into an area of other echoes depends on echo intensity, spacing between the echoes and the capabilities of the pilots and the aircraft. It can detect of precipitation drops, but does not detect turbulence significant for aviation level probability. It can analyze the displayed echoes, but does not provide assurance of avoiding instrumental weather from clouds and fog. But it is observed all safety precautions during ground operations according to the given references. And the next one is polarimetric radars. Transmit radio wave pulses that have both horizontal and vertical orientation. The horizontal pulses essentially give a measure of the horizontal dimension of a cloud, such as cloud water and ice, and precipitation such as snow, ice, pellets, hail, and rain particles, while the vertical pulses essentially give a measure of the vertical dimensions. So the advantages of this system is it is significantly improved the accuracy of the estimates of amount of precipitation, tell the difference between very heavy and rain and the hail. Identify types of precipitation in winter weather forecasts, and it also can detect aircraft icing conditions. And the additional function of this radar is detect aviation hazards such as birds. So there are also some limits of this radar, such as a radar cannot detect the height of precipitation, loses its ability to detect precipitation with increased distance. The coverage of the Earth plays a part in limiting weather detection by radar, and mountain trees can block the radar waves. So, and the conclusion of my work is in reference to the tendency of increasing catastrophic weather events, the value of radar data is also increased, because the hydrometeorological station not only can predict some weather phenomena. One system cannot always manage with the task of the weather phenomena detection. For achieving the great accuracy of weather phenomena detection and its identification, it is needed to combine different methods and means to like some complex. And therefore it is necessary to improve these methods and the systems for deeper study and obtaining more profound information. Thank you for your attention.